We're just going to look at a couple of quick examples of rounding to a specific number of significant figures. Today we're just going to look at rounding to 2 sig figs. Here we have a good mixture of numbers with decimals and without decimals. We're going to round each of these so that they only have 2 significant figures. So we're going to start here with 1,230. This number currently has 3 sig figs. If there's no decimal, the zeros at the end of the number are not significant. But I do not need this 3. This 3 is an extra significant figure that we're not supposed to represent. So if our calculator gave this as an answer and we were supposed to have only 2 significant figures, I would keep my 1, I would keep my 2, and I would change that 3 to a 0 and keep the last 0. So now the number 1,200 has only 2 significant figures. Go down the row. 875 also has 3 significant figures, but this 5 is an extra one. So if we have a 5, we need to round the 7 up. Keep the first 8, the 7 becomes an 8, and since I do want to make sure that we realize this number is 800, not 80, we have to keep a 0 as a placeholder. Remember, the zeros at the end are not significant figures. So my 2 8s are significant figures. I have 2 significant figures. The 6 can be a little misleading. Calculator can give you 6 as an answer, but you still need to have 2 significant figures in this case. So how do we do this? All we have to do is add a decimal and a 0. Zeros at the end of a decimal are significant figures. I'm going to skip over to the other decimals, since we're talking about decimals right now. 778.60. I only want 2 significant figures, so that means I want to keep the first 2. The first 7, I'm going to cut off right here, so that means my next 7 must get rounded up to an 8. But I do need to show that the number is 700, so I have to keep a 0 as a placeholder. I lose my decimal altogether. I don't need it. If I put a decimal, that 0 becomes a significant figure, but I don't want it to be a significant figure, so no decimal. Once again, now I have zeros at the beginning of my number. When we do have a decimal, the beginning zeros are not significant, so I can keep them. So far I still have no significant figures, but I want to keep 2. So I keep the 3, and once again I have to round my 4 up to a 5 because I'm dropping an 8. On this last one here in the column, I have my starting 0, not a significant figure, my 6, and once again I'm going to cut it off right between the 8 and the 4, but since I'm dropping a 4, this stays as an 8. Many times people want to round the 4 up to a 5 and then round the 8 up to a 9. That is not how we do it. What we want to do is imagine that we're just dropping a 4, and so we keep that as an 8. Right now, one a little more challenging. The 4,000. 4,000 right now has only 1 significant figure because those trailing zeros have no decimal, so they are not significant. But we only want to have 2 significant figures. There's no way to just put a decimal in here. If I put a decimal at the end, I'm going to have 4 significant figures. If I put 4,000.0, I would have 5 significant figures. So if I want to have fewer significant figures than the number shows and maintain the size of that number, I'm going to have to use scientific notation. 4.0 has 2 significant figures, but that number does not mean 4,000. In order for it to mean 4,000, I have to do times 10 to the third. 4.0 times 10 to the third has 2 significant figures, 1, 2, but it means 4,000. So this is just a few examples of rounding to 2 significant figures. We would follow the same rule for any amount of significant figures.